1.5. So 1.5 says determine the product and simplify. So we just need to determine the product and simplify. This is a very straightforward question. So 1.1.5, 1.5.1, and 1.5.1 has 2x outside. And then inside the bracket, it's x plus 2. And then we have minus 2x squared, minus 2x squared. And then we have plus 3, open brackets. This is x plus 1. Okay. So now we need to basically determine the product, right? Meaning we have to multiply, get rid of all the brackets, and then simplify by grouping the like terms until we can't do anything further. Okay. So when we simplify, when we do the product, we're going to multiply 2x with x, 2x with 2. And then here we have minus 2x squared. But look, it's not the entire term that is multiplying x plus 1, but it's only 3. So it's just 3 and that one, right? So let's do it. So it's 2x times x, that is 2x squared. And then we have 2x times 2, that is 4x minus 2x squared. And then we have here 3x plus 3, right? And so now we need to just group the like terms. As you can see, we have minus 2x squared and 2x squared. That will cancel each other out, so we don't have to write anything. But 4 plus 3, right, would be 7x, right? So it's 7x, and then we only left with plus 3. And there's really nothing else we could do. So this is the final answer. Now if we go to 1.5.2, now 1.5.2, we have a minus 3 in the first bracket, so it's a minus 3. And then it's going to be a to the power 2 plus 3a, and plus 9. Yeah, let's just check. Yeah, 3 plus 3a plus 9. And so now we just multiply each thing. So it's a times a squared, a times 3a times 9, negative 3 times a squared, negative 3 times positive 3a, negative 3 times 9, right? So what do we get? So we get that it's a cube, right? So it's a cube plus 3a squared plus 9a, and then it is minus 3a squared minus 9a, that is minus 27, right? Okay, now we look at the like terms. What are the like terms here? So a to the power 3 is the only one that is to the power 3. So there's no like term like it. Okay, so but then we look at the next one. So it's plus 3a squared. We do see that there is a negative 3a squared. So that actually cancels each other out because it's the same value, but different signs or different value signs, one being the positive and one being the negative, right? And then we also have here as well positive 9a, that is minus 9a, so that actually also cancels each other out. And then you can see the only thing we're left with is a to the power 3 and minus 27. So it's just a to the power 3 minus 27. And basically we've just done 1.5.2. Now 1.5.3, now we're looking at complex numbers. So it's 2 plus 3i minus 1 plus 3i. So this is 2. So remember, whenever you see I being used in technical mathematics, then that means you're working with complex numbers. So it's 2 plus 3i, right? And then it is negative 1 plus 3i. Okay. Is it also 3i? Let me just check, just in case copied it incorrectly. Nope, it is 2 plus 3i. So it's 2 plus 3i, yes. Minus 1 plus 3i, minus 1 plus 3i, yes. Okay, so if we tackle this one, we still do the same things that we usually do. So it's 2 times negative 1, it's 2 times 3i, that times that, and that times that. Okay, so firstly, let's do the first multiplications. So it's 2 times negative 1, that is negative 2. 2 times 3i, that would be 6i. 3 times negative 1, negative 3i. And then 3i times positive 3i. What does that give us? That gives us positive 9i squared. Okay. Now, in this case, we can just simplify it further. Now, simplify it further. Let's simplify it further. So if we simplify it further, what do we know? We know that I is actually equals to the square root of negative 1, which is literally the same as us saying, right? This is literally the same as us saying I square is equals to negative 1. So in truth, this I square that we have here is actually just negative 1. So it's negative 2, right? But then remember, it's 6i minus 3i, and that we can simplify, meaning that would be positive 3i. And then this is I squared equals 1 because I to the power 2 is equals to negative 1. So this would just be negative, or let's say 9 and then negative 1 in the place of I squared. And so then we get that it's negative 2 plus 3i minus 9. Now, negative 2 and minus 9 are the only like terms. So then that becomes negative 11 plus 3i. And that would be your solution there. Okay. So as you can see, what we did was we went through the whole process of multiplying. And we should remember when we're working with complex numbers, whenever we find I squared, it just means that it's equals to negative 1. I squared is equals to negative 1 when we're working with complex numbers, okay? Okay, so let's move on to the next question. And the next questions is question 2. So in question 2, let's see what we have. This is 14 marks. And so let's try our very best to tackle it. Okay, so now when we look at this one, so when we look at this one here, we first start off with question 2.1. And question 2.1. So question 2.1, let's see. So question 2.1. So question 2.1 says, factorize the following expression fully. And it's 2.1.1. It's x to the power 4 minus 81. Okay, x to the power 4 minus 81. Okay, that's very interesting. So let's start off 2.1. And this is 2.1.1. And this is x to the power 4 minus 81. Now notice that these two, if you think about it, x to the power 4, we could think of it as being x to the power 2 all to the power 2. But it's also at the same time 9 to the power 2, because 9 times 9 does give us 81. Can you see that? But also at the same time, remember 9 inside can be seen as 3 to the power 2, right? So in actual fact, what's going to happen here is that we're going to have to use the difference of two squares twice. Okay, but let's leave it as 9 for now, right? So let's leave it as 9 for now. So here we have difference of two squares, and the difference of two squares would give us that it's x squared minus 9 and x squared plus 9, right? Right. And then we look at the two brackets. This bracket here has now become prime, meaning we cannot factorize it, right? We can't factorize this one because we don't have a type of factorization for this. We have a difference of two squares. A difference meaning when we have two squares, right, being x squared, and 9, which 9 is actually 3 to 3 squared, right? It's actually 3 squared, or 3 to the power 2, right? Or 3 to the square. Basically, then we don't have difference of 2 squares. So this is a prime, so we don't do anything to this, and we factorize that further. So in this case, then it's x minus 3 and x plus 3, and this is x squared plus 9. And basically that would be our final solution there. So we factorized it to its furthest point. There isn't anything else we could have done. And so therefore we are done with that one. So now we go to 2.1.2. Now the rule of thumb with 2.1.2, especially in cases where you're factorizing, there's always ways to identify which factorization immediately that you should use. In this case, because there are 4 terms, the first thing you should be thinking about is grouping. Okay, so the first thing you should be thinking about is factorization by grouping, because it's 4 terms. So it's 6x squared y, right? And that's minus 10xy. And then that is going to be plus 15x. So plus 15x minus 25, minus 25. Okay. So now, because there's 4 terms, the first thing we should do, we should look at the 2 terms on their own. And what are we asking ourselves firstly? We are asking ourselves, what are the what is common between these 2 terms? And what is common between these 2 terms? So the first 2 terms, which is 6x squared y minus 10xy, what is common between them? If I think about it, I think xy is definitely common, yes. But then 6 and 10, what is common between them? It can be 2, right? 2, if we take out 2, then it's 2 times 3, which, yeah, and 2 times 5. So as you can see, so it's 2xy, right? And then that would leave us with 3x, right? And here would leave us with 5. Okay. Now we ask ourselves, in this case, what are the two, what is the common factor for 15x minus 25? And that is just 5, right? And that would be 3x minus 5. And just like that, as you can see, this bracket here is exactly the same as that bracket there. So then we move it to the front and we only write one of them. So it's 3x minus 5, and create a second bracket where we would take 2xy and 5y plus 5 and put it into the same bracket. So it's 2xy plus 5. And basically then we have our final solution. So that's our final solution to 2.1. Okay. Now let's look at the next one. So it's 2.2. Now we're going to look at basically exponential simplification question. Now this exponential simplification question, which is 2.2, so it's 2.2, and this is 2.2.1. And 2.2.1 basically starts off and says it's 3x plus 2, right? Forgive my handwriting, times 27. So 27, it's x, my handwriting is not complying, x minus 2, yes, all over 81, right, x. Okay, so what do we do in this case when we're looking at exponentials and we're trying to simplify them to the furthest point? So when we are simplifying exponentials, what we should do is this. Firstly, let's make all the bases the same, right? So we have here 3, and 3 is already a prime number, so there's really nothing we can do about it. So we could just leave it as is. But 27, if we think about it, 27 can be written as 3 to the power 3, right? So it can be written as 3 to the power 3. So we can write it as 3 to the power 3 but then we had x minus 2, so we leave it in a bracket, x minus 2. And underneath 81 can be written as 3 to the power 4, correct? So then that's times x. Right, and so from here, it becomes quite straightforward. It's 3x plus 2. First, simplify the brackets. Let's get rid of the brackets. So then it's 3x minus 6 all over 3 to the power 4x. Right. Now we have it the way we needed it. We needed all of the numbers to have a base of 3 or the same base, okay? So since now we have it as base of 3, now what do we know about exponential rules? When the bases are the same, then we can add, when we are multiplying the bases which are the same, then we can add our exponents. So then we have 3x plus 2, right, plus 3x minus 6, okay, all over 3 or 4x. Okay. Now, when we do this, so this would be 3x plus 3x is 4x. Right. 2 plus minus 6 would be just minus 4. And this is still all over 3 to the power 4x. And then the easiest way to do this is that because we know that at the top, 3 of 4x minus 4 can be separated and written as 3 to the 4x as 3 minus 4 like this, right? Then we have it like that, right? And why did I do this? Why did I separate these exponents and rewritten it in this form? It's because if we do that, then it's easy to see that we have 3 to the power 4x and 3 to the power 4x at the top and bottom. So these two cancel each other out, right? And then we are left with 3 to the power negative 4, which 3 to the power negative 4 is the same as 3 to the power 4, or 1 over 81. Right? So basically, that's your solution there. Okay, so this is how you would do 2.2. Okay, now let's move on to the third question.